Hello, my dear students. Welcome to the class of Gunn diode. So here you can see that we will now learn about an important part of microwave engineering, the microwave sources. Gunn diode is the source of microwave devices. So let's start. So first of all, there's a Gunn diode. As you can see here, it's a Gunn diode. It's a Gunn diode. So there is uh, PN diode under the Gunn diode. So Gunn diode is also known as the transferred electron device, and it is a form of diode used in high frequency electronics. So there is a pocket that you can see here. So here is a diode that has been injected with high voltage to make the high frequency, and the gallium arsenide Gunn diodes are made for frequencies up to 200 gigahertz, whereas gallium nitride can reach up to 3 terahertz. So if anyone want to transmit terahertz, so they could use gallium nitride built Gunn diodes. Now, what's the principle of Gunn diode? It consists of a slice with a buffer layer between the active layer and the substrate mounted in any of a number of packages. Depending on the manufacturer, the frequency and the power level encapsulation is also provided too. They are grown epitaxially out of gallium arsenide with silicon or selenium. The substrate used here as an ohmic contact. So there is an ohmic contact where the voltage has been injected, is highly doped for good conductivity, while the thin active layer is less heavily doped. Diodes have been made with active layers varying in thickness from 40 micrometer to about 1 millimeter at the highest. The actual structure is normally square, and so far gallium arsenide diodes predominate commercially. So it is a Gunn diode construction. So here you can see that there's a top layer. The top layer has gold wire anode. There's the anode and there's a cathode layer. Two layers are there. In the cathode layer, there is a heat sink, and there is an active in layer situation that has been built under the between these two wire anode and cathodes, and there is a gold alloy contact. It's been we added to there, and there is an N plus substrate. So this thing will create the doped N layer substrate to have a very high level of electron flow, and as there is a good conductor, the gold wires that they are out there, so they can get the better high frequency signals from there. So what is the operation of Gunn diode? That is, when a voltage is placed across the device, most of the voltage appears across the inner active region. As this is particularly thin, this means that the voltage gradient that exists in this region is exceedingly high. It is found that when the voltage across the device region reaches a certain point, a current is initiated and travels across the active region. During the time when the current pulse is moving across the active region, the potential gradient falls, preventing any further pulses from forming. Only when the pulse has reached the far side of the active region, the potential gradient will rise, allowing the next pulse to be created. It can be seen that the time taken for the current pulse to traverse the active region largely determines the rate at which current pulse is generated, and hence it determines the frequency of operation. For a normal diode, of current increases the voltage, although the relationship is not linear. On the other hand, the current for Gunn diode starts to increase once the certain voltage has been reached. It starts to fall before rising again. So that the reason why where it falls, it is known as the negative resistance region, which is found in the negative gradient or in the Jenner diode. This is the reason why it oscillates. So what are the advantages? It is much lower noise than impact diodes. Gunn amplifiers are capable of broadband operation, higher peak to valley ratio in its negative resistance characteristics, high fundamental frequency operation, increased efficiency. The applications: Gunn diode oscillator as low and medium power oscillator in microwave receivers and instruments, as pump sources in parametric amplifier. High power Gunn diode oscillators 250 to 2000 milliwatt are used as power output oscillators. Frequency modulator in low power transmitter in police and CW, Doppler radar, burglar alarms, aircraft rate of climb indicators, yttrium iron garnet tuned Gunn VCOs, voltage control oscillators for instrument applications. So Gunn diodes are also known as transport electron device. Here we conclude that the Gunn diode are basically used for high frequency oscillations. So that's all about the Gunn diode.